Hey guys, okay, so hopefully the refresher on complex numbers helped out. So we're going to start talking about graphing these things. How do we graph these? Well, it's pretty intuitive actually, and I bet if you look at the XY axis here, you can kind of figure out what's happening. It's actually not an XY axis anymore. We're now graphing this where the X axis has become all of our real numbers. And can you imagine what the y-axis be? Imagine. It's the imaginary numbers, right? So we have all of our reals going on the x and all of our imaginaries going on the y. So if we wanted to graph something like 2 plus I, we'd go 2 on the imaginary and 1i. Sorry, 2 on the real axis and 1i on the imaginary. That would be 2 plus I. If we wanted to graph something like 4 minus 3i, we'd go 4 on the real, negative 3i on the imaginary. Now, if we get something a little bit trickier, say something like just 3i, well, what's that number? What's the real number in front of 3i? It's a 0, right? So we're going to go 0 on the real and just 3i on the imaginary. Awesome. So I will let you plot number 2, and you can check to make sure you're doing those correctly. Let's go on to number 3. So now we're going in the other direction where I'm giving you points, and I want you to label them for me. So if we're looking at A, we are going negative 2 in the real and 3i in the imaginary. Negative 2 plus 3i. Let's do B. We are going 2 in the real, 3i in the imaginary. And let's do, last one we'll do is E. So let's say this is going 1 in the real. And how many is it going in the imaginary? Well, 0i, right? Or you could just write 1. So I will let you finish those and finish number 4. And make sure, pause the video here. You can check the answer key on the slide to make sure you're getting the right answers. So the next thing I'll be asking you to do is take these expressions, simplify them, and then you'll have to graph. So I'm guessing most people's intuition for simplifying this would say distribute that 4. We'd end up with negative 8 plus 4i, which is perfect. That is the simplified form, a plus bi, and then we'd graph it. We'd go negative 8 on the real, 4i on the imaginary. Good. We'll do one more together. Let's look at number 6. Say we wanted to distribute this 2i, we would get 6i minus 4i squared. Now, keep in mind, what is I squared? Hopefully from the refresher, you remember that I squared is negative 1. So we end up with 6i plus 4. Technically, the correct way of writing a complex number is the real always goes first. I'm not going to be a big stickler on that, but just make sure you're graphing it correctly. We're going 4 on the real, 6i on the imaginary. Great. I'll let you guys do 7 and 8. Make sure you check the answer key that you got the right answer. Perfect. So last thing we'll do here is we're going to need to be able to solve these equations. Again, if you recall from the refresher video, first thing we check for is factoring. Then we check, can you isolate x? Then we check for the quadratic formula. Honestly, I usually check, can I isolate x first? Well, I can't. There's multiple x's here. I can't combine those like terms, so that's no good. And then I usually just go to the quadratic formula right away, but you could check if it's factorable. I'll save you a little spoiler. It's not. But I usually lean towards the quadratic formula, especially if we're working with complex numbers, because that's usually where they come from. And so I will write out the quadratic formula for us. X equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So before we do that, we have to set this thing equal to 0. So we're going to subtract 4x, we get x squared minus 4x plus 13 equals 0. And we'll go right into the quadratic formula. Of course, you can check if it's factorable. Multiplies to 13, adds to negative 4. Not going to happen. So right into the quadratic formula. X equals. This is our A. Our B is negative 4. Our C is 13. So it'll be opposite of B, which would be 4 plus or minus the square root of B squared minus 4 times by A times by C all over 2A. Whenever you do the quadratic formula, you're really just simplifying the radical every time. So we get x equals 4 plus or minus the square root of 16 minus 52 over 2, which is x equals 4 plus or minus square root of negative 36 over 2. And again, you are only simplifying the radical every time. That's really all you have to do for the quadratic formula. So we get x equals 4 plus or minus 6i all over 2. Last thing we check, does 2 divide into 4 and 6? It does. So we get x equals 2 plus or minus 3i. Again, how many solutions are there? Well, there's 2 solutions, right? There's x equals 2 plus 3i and x equals 2 minus 3i. Again, don't forget, you're going to get 2 solutions, and it's super important that you know that, right? If the degree is 2, we should be getting 2 solutions. You'll need to plot both. 2 plus 3i, 2 minus 3i. And that's it. Cool. So let's do one more problem together. You can pause it here if you want questions. So, what's the answers there? First thing I notice about this problem, there's 1x. We can absolutely go through and isolate the x. So I will go through and just try to get x by itself, and I'm going to whittle my way down. Minus 4, 2 times by x plus 3 squared equals negative 18. Divide by 2, x plus 3 squared equals negative 9. Got to take the square root. Again, don't forget that plus or minus. That's where we get our 2 solutions. So we get x plus 3 equals 3i. Plus or minus 3i. And then we're going to subtract 3, and we get x equals negative 3 plus or minus 3i, which again, our 2 solutions are x equals negative 3 plus 3i, and x equals negative 3 minus 3i. And those are the 2 solutions that we're going to go ahead and plot. Negative 3 plus 3i, negative 3 minus 3i. And that's it. There is one more problem down here, number 11. I'll let you do that one on your own. Hopefully this makes sense. Finish up the note sheet, check the answers with the key. Thanks.